Welcome back to our chapter 1 lesson, limits and continuity. This time we're going to talk about limits at infinity. Our objective is to illustrate and evaluate limits at infinity. In this section, we are going to observe the behavior of a function as independent variable increases or decreases without bound. So this is in connection with the previous lesson and talks about infinity. So here, consider the function defined by f of x equals 1 over x. The table shows here some large values of x. So it starts from 10, 100 until it reaches 100,000. And we have the value of the f of x. Notice that as x becomes larger and larger, so then nagkadako ang value kang x. So from 10, it becomes 100, 1,000, 10,000, 100,000. The values of f becomes what? Become closer and closer to 0. So from 0.1, it becomes 0.01 until 0.0001. So sa din nagkadako ang value ni x, nagkagamay pod ang value ni f of x, nagkaduol siya sa 0. So using also the figure below, notice that as x moves to the right, so from here, padungad to, so take note nga, here 1, 2, 3, nagkadako ang value ni x, from x sub 1, x sub 2, x sub 3. I-compare na to sa f of x sub 1, f of x sub 2, f of x sub 3. Sa dahil nagkadako ang value ni x, nagkaduol ang bend sa f of x padung sa 0. Thus, we say that the limit of f as x increases without bound, so dahil x nagkadako without bound is 0. So we write limit of 1 over x as x approaches positive infinity equals 0. So positive infinity siya because this side, the right side. So kung balikon, limit of 1 over x as x approaches positive infinity equals 0. Now observe also kung say mahitabo sa values of the function f of x as x becomes smaller and smaller. So from negative 10, we have negative 100, negative 1,000, negative 10,000, negative 100,000. So smaller and smaller. So the values of our f of x become closer and closer to 0 as x becomes smaller and smaller. So this is what we call the limit of f as x decreases without bound is 0. So si x pod decreases without bound. So nagpadayon, it is infinity. We write limit of 1 over x as x approaches negative infinity equals 0. So the limit obtained are called limits at infinity. And they use the symbol x approaches positive infinity and x approaches negative infinity to denote that x is increasing, nagkadako, or nagkagamay, decreasing without bound. So those symbols do not mean that x will soon approach a particular large or small real number. So wala siya nag-mean nga pohon moabot ang x sa usa ka particular nga dako or gamay nga real number. Kay ang positive infinity ug ang negative infinity are not real numbers. Okay? They are just symbols that we use para as indicator to indicate that non-stop increasing or decreasing behavior of the independent variable. So positive infinity and negative infinity are just symbols and they are not real numbers. Nagpakita lang na siya og non-stop increasing or decreasing. So let's have the definition. 1.5.1. Let f be a function defined on C and positive infinity. Open interval C and positive infinity for some number C. So take note, our positive infinity is at the right side. So kung baga sa Cartesian plane, the right side of x is the positive one. The limit of f as x increases without bound is L, which is written as limit of f of x as x approaches positive infinity is equal to L. If the values of f of x get closer and closer to one and only one number, L, as x becomes larger and larger. So nagkaduol sa usa ka one and only number L sa dihang atong x nagkadao ko. That is increases without bound. And the other one, definition 1.5.2, let f be a function defined on open interval negative infinity. We have also D for some number D. The limit of f as x decreases without bound is L, which is written as limit of f of x as x approaches negative infinity equals L. If the values of f of x get closer and closer to 1 and only one number L as x becomes smaller and smaller. Okay, so let's have theorem 1.5.1. Let R, the exponents, be any, take note, positive integer. So, dapat siya positive, dapat siya integer. Ang atong R, which happens are exponent. Limit of 1 over x to the power of R as x approaches positive infinity equals 0. And limit of 1 over x to the power of R as x approaches negative infinity is also 0. So let's try some of its examples. So evaluate its given limit if exists. Example, limit of 5 over x cubed as x approaches positive infinity. So first, put equal sign. And then, 5 over x cubed can be rewrite as 5 times 1 over x cubed. So we have limit of 5 times 1 over x cubed as x approaches positive infinity. Okay? Now we can perform na using the limit theorems. So limit of 5 as x approaches positive infinity times limit of 1 over x cubed as x approaches positive infinity. So we know that the limit of 5, so pag constant, ang limit niya is the constant itself, right? Times the limit of 1 over x cubed as x approaches positive infinity. So take note, our R, so nisod na siya aring theorem, 1 over, right? And our R is positive integer. So as x approaches positive infinity, so the answer is 0. So 5 times 0, the answer is 0. So the limit of 5 over x cubed as x approaches positive infinity is 0. So that is our first example. Now for our second example, we have limit of 2x plus 3 over 4 minus x as x approaches positive infinity. So kani medyo di siya kapareha sa previous example. Atong buhaton karon is atong i-divide ang numerator o denominator sa highest degree or degree of the polynomial sa denominator. Then, the degree of this polynomial, meaning the power of the variable here, the highest is ay 1. So, ang atong himoong divisor ron is only x. So, ito i-divide ang numerator o denominator sa x. So, in this example, ang atong denominator is 4 minus x. Kunya, i-divide mo na itong numerator denominator sa x no, tapos ang iyang exponent magdepende sa degree sa polynomial. So we have 4 minus x. Ang degree sa x is 1. So we get x to the power of 1 or simply x. Okay? So we have this one. Limit of 2x plus 3 over x. Tapos 4 minus x over x as x approaches positive infinity. Next, simplify. Limit. So we got 2x over x plus 3 over x. And then 4 over x minus x over x as x approaches positive infinity. Yan. So limit. What is 2x over x? That is only 2 plus 3 over x over 4 minus x minus 1 as x approaches positive infinity. Okay. So here we can apply now the limits, the theorem about limits. The limit theorem. We have limit of 2 as x approaches positive infinity plus limit of 3 over x as x approaches positive infinity over limit of 4 over x as x approaches positive infinity minus limit of 1 as x approaches positive infinity. Next, what is the limit of 2? 2, syempre. Plus the limit of 3 over x. So by the theorem, we have our r is 1, positive infinity. Automatic 0 gihapon, di ba? Here, 0 ang answer. Bisan pag positive infinity na or negative infinity. Basta we have x and we have r. Exponent must be a positive integer. So here our r is 1 over limit of 4 over x equals 0 minus limit of 1, 1. Next, 2 plus 0, 2. 0 minus 1, negative 1. So 2 divided by negative 1 that is negative 2. So therefore, the limit of 2x plus 3 over 4 minus x as x approaches positive infinity is negative 2. Okay? Next, limit of x squared plus 2x plus 1 all over x cubed plus 4 as x approaches negative infinity. So, the same atong buhaton sa numerator o denominator. We need to divide it by x. Depende kung ang exponent ni x sa degree of polynomial sa denominator. So, we have denominator na to is x cubed plus 4, right? And atong i-divide ang numerator denominator sa x, tapos ang exponent magdepende sa degree of polynomial sa denominator. Happens nga iyang degree is 3. So we have x cubed. Okay? Next. Limit. So, x squared plus 2x plus 1 over x cubed. Taubos pod, x cubed plus 4 over x cubed. As x approaches negative infinity. Next, limit. So, x squared over x cubed plus 2x over x cubed plus 1 over x cubed all over x cubed over x cubed plus 4 over x cubed as x approaches negative infinity. So, limit x cubed over x squared over x cubed, that is 1 over x, plus 2x over x cubed, that is 2 over x squared, then plus 1 over x cubed. This is x cubed over x cubed, that is 1, plus 4 over x cubed as x approaches negative infinity. Okay, now let's apply the limit na. We got limit of 1 over x as x approaches negative infinity plus limit of 2 over x squared as x approaches negative infinity plus limit of 1 over x cubed as x approaches negative infinity all over limit of 1 as x approaches negative infinity plus limit of 4 over x cubed as x approaches negative infinity. Okay, so limit of 1 over x as x approaches negative infinity, that is 0, based upon sa atong theorem nga 1.5.1. Okay? Plus, ang limit of 2 over x squared, that is, the limit of 2 is 2, times the limit of 1 over x squared is 0, plus limit of 1 over x cubed as x approaches negative infinity rather, is 0 also. Over the limit of 1 is what? 1. Plus the limit of 4 over x cubed, that is 4 for limit of 4. Tapos limit of 1 over x cubed, that is 0. Okay? So sa ibabaw, 0 na. Sa ubos is 1. So the answer is 0. So the limit of x squared plus 2x plus 1 over x cubed plus 4 as x approaches negative infinity is 0. Next example, letter D. Limit of x to the fourth power plus 1 over x squared plus 3x as x approaches negative infinity equals. So the same gapon na, i-divide na to siya sa x, ang numerator ug denominator, tapos ang exponent ni x magdepende sa degree of polynomial sa denominator. So we have x squared plus 3x. The degree of polynomial is 2. So x squared na siya diha. So ato i-divide ang numerator ug denominator sa x squared. So x to the fourth power plus 1 over x squared all over x squared plus 3x over x squared as x approaches negative infinity. Okay, simplify. Limit x to the fourth power over x squared plus 1 over x squared over x squared over x squared plus 3x over x squared rather, as x approaches negative infinity. Okay, so limit x to the fourth power over x squared, that is x squared, plus 1 over x squared all over 1 plus 3 over x as x approaches negative infinity. So we have limit of x squared as x approaches negative infinity plus limit of 1 over x squared as x approaches negative infinity over 1 limit of 1 as x approaches negative infinity plus limit of 3 over x as x approaches negative infinity. Now, what is the limit of x squared? The limit of x squared is, diba? Depende siya sa a. So, we have negative infinity, right? So, negative infinity siya, okay? Squared plus limit of 1 over x squared, that is 0. And then limit of 1 is 1. Limit of 3 over x, that is 0 also. So we have negative infinity, the square of negative infinity over 1, right? So what is the square of negative infinity? Siyempre, positive infinity over 1. So the answer is positive infinity. So limit of x to the 4th power plus 1 over x squared plus 3x as x approaches negative infinity is positive infinity. It is positive infinity. Okay? Now let's have the last example. Limit of x over x square root of x squared minus 1 as x approaches positive infinity. Observe that as x increases without bound, x greater than 0. So, our x is equal to square root of x squared. Right? So, ang nakalahian is sa previous nga mga example, we have a denominator which is a radical. Okay? So, here, we have equals limit of x over square root of x squared minus 1 as x approaches positive infinity. So, take note pag may radical sign sa denominator, we need to multiply it also. Right? Para matanggal ang radical sign. So, ang sama itong gamiton. So, that is, sa ubos, we need to multiply it by square root of 1 over x squared. Sa denominator, we need to multiply it by square root of 1 over x squared, which is the same also sa numerator, right? Okay, so you have square root of 1 over x squared. So equals limit of x over square root of x squared minus 1 times, take note, here, we can simplify square root of 1 over x squared as 1 over x. Here, we have square root of 1 over x squared still as x approaches positive infinity. Okay, limit of x over x, the numerator. Denominator, we have x squared minus 1 times 1 over x squared as x approaches positive infinity. Okay, so I have limit of 1 over x squared minus 1 over x squared as x approaches positive infinity equals limit of 1 over x squared minus 1 over x squared as x approaches positive infinity equals limit of 1 over 1 minus 1 over x squared as x approaches positive infinity. So next, we have limit of 1 as x approaches positive infinity over limit of 1 as x approaches positive infinity minus limit of 1 over x squared as x approaches positive infinity. So limit of 1 as x approaches positive infinity is 1. And also here we have 1. And limit of 1 over x squared as x approaches positive infinity is 0. So we get 1 over 1 equals 1. So the limit of x over square root of x squared minus 1 as x approaches positive infinity is 1. So that's it for our topic, limits at infinity.